a bunch of those statements in like in sequence. So where you guys can simply look at those statements, so that you guys can look at those statements, so that we can see how to apply those statements, how to use the SQL code statements in our practical examples. But anyway, the moment that we're done with the database theory, and then we're going to start on the practical side of the database. Thing is, I do not want to, stagger up theory, practical, theory, practical. I do not want to do that. I just want us to finish up on the theory section as soon as we're done with the theory section, and then we can go back and then we can look at the practical applications, that as soon as it's fresh, and then you guys can utilize that also in your project. So that is what I just want you guys to simply do. And as I said, that there is some certain aspects that we are going to need to learn. Like there are certain things that we need to learn. For instance, we are still going to look at Node.js. We're going to look at Node, because Node is what is going to help us to uh, to read from the databases. So yeah, so that is what we're going to do. We're going to learn a little bit of Node so that we can learn how exactly it works, um, on how exactly it works with the database. So that is what we're going to do. And for you guys to learn Node, so what I did, I took the liberty of um, I'm going to send you a link for a website where you guys can learn a little bit of Node using, because it's Node.js. So basically, it's using JavaScript for you guys to learn how to use Node. So for those of you that want to learn ahead, this is something that you guys can do. You can simply learn ahead. You can teach yourselves a little bit of Node. I just took the liberty. I just sent the link on the on the what you call on the chat forum here. So you can just look at it from the chat forum there. Just go through that entire thing. It's like okay, there's a bit of work to do, obviously, but you understand that for those of you that did PHP, basically there isn't much difference with PHP. There isn't much difference with PHP for you to learn how to read data from a database and stuff. There isn't much difference there with PHP. But as I said, that we're going to be using Node.js for us then to read JavaScript code from a normal from your website, and then to be able to access it. So yeah, we have a bit of work to do as we're putting it, but as I said, the trick is you understanding your JavaScript. The moment that you understand your JavaScript, the more that you guys are learning or you are doing your JavaScript, you understand that it is quite something simple to do. And then for those of you that want to know how exactly Node.js can be used in MySQL, like in the app there's a tutorial there in W3 Schools that you can go through. So you can also go through W3 Schools, and then you can also learn from that side, also from W3 Schools. And then you can teach yourself with W3 Schools. There's those practical examples that you can try so that you can master the code a little bit faster. And then from there, and then you can use that other website, that Node.js dev, to learn it, because now the Node.js Node.js .dev page, the one that I sent on the app here on the chat, is the website of the company that actually developed this whole Node.js. And then for if you want to learn more in detail, and then they've got even certifications that you can do, that you can literally certify yourself, like for so that you can be certified. Like if there is one thing that I'll let you know about, especially this whole development field that you guys are embarking on right now, is you understand that like a lot of developers that you meet out there in the world, as much as some of them went to university and some of them didn't go to university, one thing that they have in common is certifications come first before anything. Like most companies, they will prefer you to have a certification. Like they'll always prefer someone to have a certification before anything. So a certification in the technology that you're doing, whether it's going to be not uh rather have a certification that if you want to do Java, have a certify yourself in Java. Um, Amazon, certify yourself in Amazon. Like anything that is Oracle, you can certify yourself in it. JavaScript, I'm not so sure. I'm not so sure. I've never seen a JavaScript certification before. Anything that comes, probably JavaScript will be. I'm pretty sure will be just these other companies that are just running their own thing. But there isn't much certifications there for for JavaScript. But as I said, you can always check. There is always places where they offer certifications for for some of these, like you've got your Udemy's and things like that. But JavaScript though has got an examination. The examination called I think JSE something something. You guys can always just look at it also, and then try to pursue those certifications on your own spare time. Try to pursue those certifications on your on your spare time and see um, if you can. Then there's like an entry level certification, and then there's associate, and then there's like professional certifications. Then you can always proceed with those ones there. Uh, and those exams are pretty much tough. I would tell you that. That's one thing, and they're not free. Because now, as I said, that they're pretty much tough because one is the pass mark is like 70%, and then yeah, and then they are also testing you. Maybe you find out between 30 and 60 questions, and then now when they say 70%, which means literally you need to get almost everything right. You need to get almost everything right. So you are looking at what 23 out of 30 minimum. So which is a lot. But yeah, as I said, at the end of the day, it is up to you. So my advice will be just pursue the certification so that you can increase your employability if you are a person that's looking for employment. And then if you're thinking of opening your own business, do the certifications because they actually allow you to have more in-depth knowledge. You'll be more like you'll know more, even if you do not need to do it now because of, like, the finances part of it. So what you can always do is you can always I'll do that, Michelle. You can always, just study those exams so that you can also, equip yourself so that you can always know. But yeah, so yeah, on this note, then I think we can continue with where we left off last time. So today I want us to look at, like we've looked at application and how to make use of SQL. So then today I want us to look at testing programs. Now, test programs for a computer application that access a database using SQL. So now the trick here is, how then do we test programs that actually use SQL? How do we test those programs? You see that? So that is what we have. Just give me a second here. Troy, you can ask your questions. Okay.
Hi, say yes.
Yeah. What's up,
Yeah,
Troy?
yeah,
Yeah, I
yeah.
can hear you.
Yes. Based on what you said, in terms of Node.js, right? And you
Yes.
said that it's similar to PHP. So while we're using PHP, there was an external source which was XAMPP as part of, I would say, as part of the server side of things in order to monitor the database. So how is that Node.js capable of pushing the whole database without the external server? Yeah,
Uh,
yeah.
the external server that you are using this time is MySQL. We're not using XAMPP. We're using MySQL because MySQL is more industry related. XAMPP mostly is used for when you're using when you're developing for your own computer. Most of the times when you're developing for your own computer, you're not really developing something big. You're simply developing something small
Okay.
or something that can handle like not many requests. So hence they will use XAMPP. XAMPP is mostly used for practice and stuff like that. But for you now to work on a larger scale, you need something like MySQL. It develops better with servers.
Okay.
Yeah.
So would you say in that context that XAMPP it's for private use and then Node.js is for vast popularity or large people in terms of maintaining the capacity of the whole popularity
Yes,
or
precisely.
population rather. Yeah, yeah,
Yeah. So with XAMPP, as I'm saying, like XAMPP is more small scale, but
yeah.
MySQL is more um, industry orientated, and it's like the reason why I would prefer to for you guys to make use of MySQL is because it's a technology that is similar to technology that you find, especially if you're going to go to work, or if let's say a client comes to you right now and says,
Yeah.
I need ABC. And most of the times when clients they come to you in that you need to test on a bigger platform because you do not know how much traffic they're going to generate. So now if you start small and then it will tend to also give you a bit of problems later now if you have to test with a bigger with a bigger like larger traffic if I put like that.
Yes, yes.
Yeah.
So in essence, if you are building a database that is based on obviously larger scale of people, so we would go for Node.js and also managing the financial aspect of things.
Precisely. You see now, not.js is even more secure compared to XAMPP. It gives you more security and it has more support compared to like as much as XAMPP has support and stuff, but
Yeah.
not.js has got like a very big community in terms of support and stuff. So literally, like when it comes to security and people,
Yeah.
you know that you always have the support that you need, especially if anytime you meet any problems, there's always like a huge community of support behind you.
Okay. Okay.
Yeah.
Now I get it. I get it. All right. Thank you very much.
Okay, try. Michelle, I saw a hand from you.
No, sir, I made a mistake.
Is it? Okay.
Yes, sir.
All right. Now, um, as Troy was saying there, yeah. So like the reason why I mostly emphasize on you guys using the technologies that are being used out there is because I want your skill set to be relevant because like technology changes a lot and we need to keep up with it. So even if when you guys are doing your training right now, you need to train with current technology so that you guys are always current. Because like I want like the moment that we are done here, even in the next month when you guys are done, I want like when you guys leave here, when you guys leave, when you guys go to your workplaces, whatever, like whenever they will bring something up like this, I want you guys to be able to like, oh, I know this. Even if you are not 100% fluent in it, and then but yet you still know you still can say, oh, okay, I know where to start from, because it's easy you meeting something that you already have a clue about than you meeting something that you have never seen in your life. So, that practical experience from the industry, that is what we're looking at. But yeah, now going back here, testing the programs for a computer application that accesses a database using SQL. Now, after you've developed, or after, let's say you have developed your application, your project in this case, after you have made your application, you have developed your application from the designing stages all the way moving down, all the way to the you building on HTML using CSS. And then for those of you that will do a little bit more research, you might have to use SASS also as well. Excuse me, which is SASS as well. And then you are going also to learn JavaScript, as we have been learning JavaScript, and then making use of JavaScript there. And then for some people, I'm pretty sure they will prefer to use, like, to build the front end of most web apps. Some of you might even learn something called React, which is a very good language, especially, and it's not a language, it's a platform that you use to build front end sites, like the front end of your websites there. So we're going to make use of that. All right. So as I was saying that now, when you develop, like, your steps for developing your app, there is a bunch of steps there. Like, one, there is the planning and researching phase, obviously, and then there is the structural design part, of which in the structural design part, this is where now you decide, actually, especially during the planning phase, you're going to decide there, how exactly am I going to build this app? What frameworks am I going to use? Am I just going to use HTML and CSS? Or am I going to make use also of other aspects? Like, for instance, as I was saying to you, that there is something called React that you guys can learn, which basically uses JavaScript, but it's React. The React is used to build your front ends, the stuff that you see and interact. It actually makes it easier for you to build your website, especially using React. But now for you to understand React, you have to understand CSS and HTML, obviously, for obvious reasons. But this is something that you guys can teach yourselves with time, or you can even start teaching yourself. It won't take much time. It's just something maybe that can take you, if you're really, really serious about learning it, and then it's something that can take you like a week if you put in like maybe 4 hours a day or so. It can take you literally a week for you to master the or to get a hang of it. But yeah, I was saying that you can make use of that, and then you do your JavaScript, and then from there, and then we do the node, which is the joining of the database and stuff. And then after you're done with that, and then now there's something called debugging. So testing programs, and this is a very essential part of development. So as long as you're a developer, you need to understand this this particular part, testing. So all programs that you develop, they need to be tested. Because now, how does it help you that you develop a program and then you send it back to the client, but you didn't test it? You don't have proof that it actually works or that it does the work that you think that it's supposed to do. So we need to understand that part there. So now the typical debugging process starts here. So in saying that normally the first step in debugging, because here testing a program is basically checking if that program has got bugs or not. So now I'll start from explaining basically what debugging is as a process. So now when you're talking about debugging as a process here, we're checking if the program follows or checks all the program logical parts. Is it doing what it's supposed to do? Is it producing the results that it's supposed to produce? For instance, if let's say I want to pull out names of people that are owing me, and I write an SQL statement there, select name, surname, account from TPL clients, where account is maybe, let's say I want accounts that are on a negative. Then I say where account is -1 or is less than 0. Let me just say less than 0. So now the moment that say less than 0, so which means all the accounts that are on negative, which means these are accounts of people that are owing me. So I want to show the results of all those people. And then now, if my code, whenever I'm doing my project there, and then I press a button that's supposed to show people that are owing me, and then that button shows me results that are incorrect, which means there's something that was wrong in my code somewhere, which means that thing needs to be fixed. Hence, the reason why we need to test before you can even send to the client. You need to test so that now when you do that, you are literally preparing yourself for something called debugging. And then now a bug, then that brings the question now, then what is a bug? What is a bug? So now in development, a bug now we'll be talking about how can I put it there? I'm trying to find a word like a bug, like when you're dealing with a bug in software. So a bug is literally an error or a flaw, if I can put it like that, or a fault that exists in code. So now that error that you have in your code is something that is called a bug. That I think there is no better explanation than that. So now you need to have those bugs fixed. So any unexpected program, any unexpected problem, or any wrong answer that you actually experience whenever you are coding, that wrong answer is typically what you call a bug. That is what it is. That wrong answer is a bug. You see that? So now, how then do you fix it? So now, one thing about bugs that is they are an inherent part of software development. And now, when I was saying inherent, was it's a it's something that, no, as much as it is unexpected, but it's something that you as a developer is you are bound to face. Something that is faced almost each and every time. So you need to resolve it. You see that developers, they need to analyze the code that they write, hence the debugging part. They need to analyze the code that you have. But now the problem is, now let's say you've written a program. For instance, you wrote an app for Absa Bank, FNB Bank. How are you going to be able to follow each and every code that was used when people were designing? So now when you're talking code here, we're not talking HTML anymore. We're talking JavaScript code. That's what we're talking about. We're talking the SQL code. We're no longer talking HTML now, because HTML is not a coding language, by the way. So that there was just a language that was introducing that we introduced for structural design. So whenever we're talking coding, we're talking JavaScript, we're talking Python. Those are the languages that we're talking about there. So just in case, if someone asks you which languages are you fluent when you're coding, you can't say HTML, because HTML is not a language, by the way, guys. As much as it says hyper markup language, it's just like SQL. SQL, as much as a query, I mean, a structured query language. Also, it is not essentially a programming language. It's not. It's just a structural language, just like HTML. And then HTML is a structural language for creating user interfaces, while this SQL is a structured language, but for requesting queries. And then now, when you're talking about these programming languages, this is what we're talking about. We're talking about things like JavaScript, we're talking about things like Python. Then now, how then do you debug? How then do you go through? You see that? So now, your job as a developer is sometimes you'll be hired not to design, but you'll be hired just to identify and fix errors. There are other people, like departments are made up of people like that. Your job every day is to wake up, sit down in front of a computer and fix problems. That is your job. For some people, that is their job. For some people, they are hired to design. Personally, I'm not a fan of creating. I'd rather be fixing. That is my choice. But other people, they are so creative that they prefer to actually create. So that is the reason why I fancy myself as a back-end developer, because I work best like dealing the coding part and stuff without touching the whatever the people use, the interaction or the user interfaces, because I feel better coding and solving problems and stuff. That is what I actually like doing. But now, as I say, that you like software engineers and developers, they work to identify and fix the bugs during the testing and debugging phases of any project. So hence, as I'm saying, that you guys are also going to go through that. Like if you remember that project timeline that I showed you before, like I think that was last time when we were showing you the projects, like that you need to have like a project plan where you're saying, okay, my project has started, this phase, this phase, this phase. And then if you notice there, at the end, there was the testing and the debugging stage, of which it was also like a lengthy process that was like almost 2 weeks long, because this is what you do before you release any software. It needs to be tested and debugged. You need to remove each and every mistake that is there, identify and fix those mistakes there. So now, that debugging process. Now, we say that the first step to debugging is to attempt to reproduce the problem. That is the very first step there. Reproduce the problem that you've been given, and then now reproduce it. Now, when saying reproduce, you're basically giving the problem a real life scenario that you can be used so that you can see if you can produce results that are fitting or that are expected. For instance, you can simply even write it down. Write down using a piece of paper, piece of paper, and then say, okay, this is the input that I'm going to put, and this is the output that I expect. And then you just run your program and check if you input what you inputted and it gives you the expected output. So it means technically maybe you're right, or there might be a bug, but you see that the whole point is use a specific user environment, and then from there, and then make it difficult to reproduce the problem. You see that? So now try to see if you can literally get the desired result from your project or from whatever system that you have designed. So now, after a bug is reproduced, the input of the program may need to be simplified to make it easier to debug. E.g., a bug in a compiler can make it crash when passing some large source file. Like for instance, in this case here, was talking just now with Troy. You guys were listening through. Well, you was asking about XAMPP. There's something also called AMPS, which basically works like XAMPP. So the XAMPP, there's AMPS. They basically do the same thing. They make you design a database using something called PHP admin, which is when you are using my PHP. So my PHP admin, so which is basically PHP, which basically makes an SQL database, by the way, but on a smaller scale. But it's still a database at the end of the day. Still works at the end of the day. So now the question then was, okay, if we take some certain lifetimes, like some certain life scenarios, and then we plug it in an app that is not supposed to handle a lot of traffic, how is it going to work? You see, so these are the types of user environment or specific user environment that you want to reproduce, because we want to we want to get an error on purpose, because that is the whole point. Like you give it so that you can see how much limit your project can take. You're giving it a limit so that you can see. Like for instance, here they're saying that a bug in a compiler can make it crash when passing some large source file. Like for instance, you put a database or a text file or an array that is so big that your program cannot accept, and you know that it can't accept it, but you want to see the limit of how much content or how much data your project can handle, or how much traffic your project can handle. You see that? So those are some of the things there. So, however, after simplification of the test case here, only a few lines of the original source file can be sufficient to reproduce the same crash. You see? So now that is the whole point there. You trying to see how much your project can take. Is testing the limits. Like what test pilots do to test airplanes. I don't know if you guys have watched documentaries before, especially on how they actually test airplanes, but this is one of the things that they usually do. They, like, the designer has got specifications. Like the designer has specifications. Like Boeing will manufacture an airplane, and then they'll tell you that this airplane here has a flight ceiling of 47,000 feet. And it has a maximum speed of 570 nautical miles an hour. And and then from then they'll have some other smaller specifications. They've got the maximum weight that they allow, maximum fuel that they allow, all of that stuff. But during test phases, they will use maybe at first they will test using certain limits, like certain aspects that are within the safety parameters. So for instance, they'll put just enough fuel, they'll put just enough load, they'll fly the required ceilings and everything, they'll fly around and check. Is my plane working properly? Then they're seeing how it's actually responding and everything, and then they will land. But then later, when they're doing some very extreme tests, now one is either they will overload the airplane, and then two, they'll fly it way above the ceiling just to check the structural integrity. They'll be listening in, they'll be checking, they'll put sensors all over to see as to, okay, if we pass the flight ceiling by maybe 1,000 feet, how is it going to respond? Just in case some crazy pilot decides to do that. So they want to see how it's going to respond. That is exactly the same thing that you do as a software developer. You will have, like when you're designing your app, when you're designing your web app, your portal, your website, whatever, you've got a limit. Like, okay, this is how much data I can handle. But when you're testing now, you want to see, okay, I know how much at least I expect, but let me put more. Let me just see what's going to happen, and then you'll be surprised. Sometimes it can work, sometimes it won't work. Depending, sometimes it can work because of the internet. So you need to list all those conditions because you want to test, you want to check. You see that? So hence now, and then from there, if any bugs come through, and then you need to see why you have those bugs. What was the problem? What was the cause? Because already you know that the cause is because you put more than it's supposed to handle. But now, why? Why did it respond the way that it responded? Hence, now when you're debugging, you're not simply just looking at the lines of code also. There are softwares that you're going to be making use of. There are tools that you'll be making use of that will actually write reports at the end to tell you, oh, okay, this place here, this happened because of that, or here you didn't do a proper conversion, or your conversion was fine. It's just that your conversion can, like for instance, there's a difference between an integer and a float. And also floats are different themselves. Like they are very different floats. Like we spoke about this float there, about floats in JavaScript. So now if you remember, um, if you remember, when you spoke about floats, we spoke about a bunch there, but there's a bunch of them. There's a bunch of them. There's limits. Like when, especially if you're dealing with other with other languages, you notice like languages like, let me see, um, languages like Python, like Java and stuff. They've got four different types of like not flow, like not four, like they've got a bunch different types of floats. So they've got like doubles. Then they have a float, and then they have so many different types of floats. So many different types of those also of those floats. So now the question then would be, then when you are coding, how do you know which float that you're supposed to use? You see that? Because there's a difference there. Like in JavaScript, for us, for floating point, there's two types. There's what they call a float, and then there's what we call a double. There are two different types, and both of them can handle fractions. Both of them can handle fractions, but you need to understand which one that you need to use, especially if, let's say, I'm dealing with a lot of decimal places or I'm dealing with very big numbers there. You need to know. You see that? You need to know. So hence now, when it comes to a float, a normal float, just as an example, a normal float represents 32 bits in JavaScript, while is a double represents 64 bits. Now, if you look at that aspect there, from your level 4 knowledge, you understand that whenever you're dealing with these aspects, with these two aspects there of a normal float and of a normal float and a double, especially in terms of space allocations, you know the difference between what we mean by 64 and 32-bit. You guys know that by space allocation by now. Binary, if you have forgotten, just go back to your binary and understand that you know that 64-bit is bigger than 32-bit, obviously, for obvious reasons then. So now, because of that, and then you need to know how, like if you experience a certain problem, why are you experiencing that particular problem? Or did I use a wrong conversion? For instance, when I pass, did I pass into a float, or did I pass into a double? Which float did I pass into? I need to know which one I passed into so that it can handle like the certain amount of data that I actually need. You see that? And then so yeah, say that we can also use tracing. Tracing basically is that part of whereby you can just go through your code, which is called tracing there. Tracing is basically what they call print debugging. So now this is the act of watching live or recorded trace statements or print statements that indicate the flow of execution of a problem, sometimes called printf debugging, due to the use of the printf function in C, like if you're using a language like C there. So basically now, what you're simply doing is you are looking on your code. That is what you're simply doing. You are looking at what your code is doing. Is it printing the stuff that you want it to do? Like when your code is running through, there is some stuff that it writes. So that is what they call print debugging there. So for those of you, like we're going to look at to look at this, especially once we start when I'm done here, we're going to look at this, like some of these methods in use. And then the second aspect there is called remote debugging. Now, remote debugging is debugging a program running on a different system from the debugger. Like to start remote debugging, a debugger connects to a remote system over a network, and then the debugger can then control the execution of the program. So basically now, this is what they're saying, that instead of testing using your own system that you use to develop, use another system. Use another system to monitor that, to see how does my program react on another platform. Because you've been using this system, it can run perfectly on your computer, on your system. But now what happens when you use another system? So most times remote debugging, we mostly use, especially if you do not have another computer or you do not want to go through the headache of just designing other computers and stuff, usually install a virtual machine, and then in the virtual machine, and then you run maybe a couple of Windows or a couple of Linux, and then you run your program just to check, is it responding how you want it to respond? If I have to use another website, I use another website. For instance, I was using Google Chrome, and then I decide to use maybe Microsoft Edge, or I decide to use Brave browser. You see that? So just to check. And then there's something also called post-mortem debugging. Now, this here is debugging of the program after it has already crashed. You see, so now this here is one of the most common ways of actually the two most common ways is basically print debugging or tracing, and the post-mortem debugging. Now, this one here is basically you run your program until it crashes. After it crashes, then that program is going to write a report on whatever platform that you're using to run the program. And then that report is the one that you're going to go through, or it will simply give you like sort of an error code. For instance, if you are using languages like Java, and then you can say maybe exceptional error or something like that. Even JavaScript also does something like that, like you guys saw last time. Whenever I was running some code, and then you write some wrong code, and the next thing it's showing you something else. So now you notice that here now related debugging techniques often include various tracing techniques. You see that? So that is basically tracing, but now you're tracing after you have checked. For each, there's analysis of memory dump, which is what I was talking about there. That your code, when it's running, it will write something, and then that whole document that it actually wrote is basically what they call a memory dump. So the dump of the process could be obtained automatically by the system, as I'm explaining to you right now, when the program is terminated due to an unhandled exception, or by a programmer inserted instruction. Sometimes, if let's say your system doesn't have a way to report, and then you can always just write code, maybe on a script. For instance, you just type maybe on your MS-DOS or whatever that you are using there, and then you just write, and then from there you can um, retrieve the report. And then there's something called Wolf Fence algorithm. Now, Aldous Gauss, this was a very, very renowned computer scientist of his time. This guy described this simple but very useful and now famous algorithm in 1982. So now this is an algorithm that is actually used there that is used also for debugging. Let me break it down a little bit there. So Wolf Fence now debugging. So now when you're talking about Wolf Fence debugging, which is basically, as I'm saying, that it's it's a it's a testing method, or it's a debugging method here that is actually used for fixing, for identifying and fixing like issues or problems in a system, if I can put it like that. So now it involves a bunch of steps there. Like one is you do an inspection yourself just to check. Okay, so now what this guy did, let me put it in simple, maybe in layman. Here, let me see here. Okay, he's saying that there is one wolf in Alaska. How do you find it? First, build a fence around, wait for the wolf to howl, and stuff like that. You see that? So basically now, if you can break it down in a computer language that you understand, or in a farm language that we understand here in South Africa, the wolf fence is, you are basically looking for a problem, and then this guy here used the context of a wolf fence to deal with issues. So now he said that first is perform a physical inspection. Let's say you are running a farm, and then in that particular farm you've got animals, and then you notice that maybe at one time, and then you find that there's an animal that's missing. Maybe let's say you've got sheep, and one of the sheep is actually missing. And then at first you might not maybe take might not pay much attention, because like it's a big farm, and then maybe it might have fallen into a hole and disappeared, or a thief might have come through and stolen it and stuff. But this is where now you tend to check, okay, I'm missing an animal, but what's the first thing that you do? You're going to go around your farm and examine the fence there to check for any visible damage that you have on your fence. Are there any loose wires? Are there any broken components? Is there any place where the fence that you have in your farm that's been compromised, right? And then two, and then you're checking, like, okay, fine, I've checked that. Then my farm is electrically fenced, right? So now two, then I'm checking, like, then is the electrical fence functioning properly? Is there enough power supply to prevent the sheep from crossing over to the other side? Because now you've got that, then you're preventing the sheep from crossing, and you're preventing wild animals from jumping in. So you need that electrical fence. Is there enough? Is the power supply enough? See that then you're going to go and check. I'm going to check there. If I'm running a solar, I'm going to check. Are the solar panels functioning properly? Am I missing a solar panel? Are the batteries functioning properly? Are they producing enough power? If I'm getting a power from Eskom, is there power that is constantly? Or if, let's say, Eskom is doing load shedding the way that it's doing there, do I have enough backup power for me to run even during those load shedding hours. Those are some certain things that you see. That if I have now checking those two steps there, the one is I've done a perimeter search or a physical inspection, and then number two, I've done what they call a power supply inspection, and then which means now I need to see now, I need to test. So now I need to test. One is I will test, go each and every lock that I have and check. Is it loose? Can it move on its own? Because sometimes it can happen that a fence can fall when it's stepped on, and then it can also come up and rise. So I need to check. Is that happening? Okay, cool. If the fence is fine, then I am testing the electricity. Am I producing the desired voltage? Am I generating enough so that no wolf can actually jump in? So we're using a wolf here or wild animals as examples, because most farms, they have to make use of electrical wires for them to be able to keep wild animals away. And then the next up then is the grounding. Now we need to check now, is there proper grounding system that is working there? And then if ever there's something wrong, then I need to do repairs. You see that? And then I have to repair the damaged wires or the insulation or the connectors, so that to check if everything is in place. And then next up, then there'll be maintenance. Then I need now to maintain regularly and to see that the fence is in good order so that the wolf cannot jump in. And then if I'm not able to maintain or to identify the issue and my animals keep on disappearing, then I need to find a consultant then who's supposed to come in and fix the issue for me. So basically, this is how this whole wolf what you call the wolf fence debugging or the wolf fence algorithm works. So this is how it works there. So basically now it is useful for actually safeguarding. So now in the for safeguarding, if your code for safeguarding your application, and the wolf that you are talking about here, you see that is basically the your hackers, people that are trying to exploit weaknesses in your apps and things like that. So hence now, the steps are quite simple. Comprehend the system, test the system, locate the error, and fix the error. If you can't do that, hire someone who specializes in it, come and do exactly the same steps. Comprehend the system. They have to understand the system, obviously. Test the system. Is the system doing what it's supposed to do? Locate the error. If the system doesn't do what it needs to do, locate that particular error. And then after you've located the error, then fix the error. You see that is the wolf fence debugging. That is what we've been saying all this. You see that? So now this guy used a wild animal for him to actually relate this to something that people might relate that people might relate to, but I'm pretty sure you guys are getting the essence there. Right. And then there's something called delta debugging, which is a technique of automating the test case simplification. And then there's something called staff quiz, which is also a technique of isolating failure within the test using progressive inlining, excuse me, of the failing test. You see that? So now with delta debugging now, I'm seeing here messages from Wusi and Mfundo. Wusi is saying that a bat is something, or a bug, okay, is something that causes the computer software to have incorrect or unexpected result, which is true. And then Mfundo just emphasizing on that. Yeah. So yeah, you guys are right there. Thank you. So now that is basically debugging, and those are some of the ways that actually you deal you debug. So as I was saying that with delta debugging, there it's a technique that causes that is used to isolate the root cause of an error, for instance, in a program, and then that basically operates almost similar to the offense, but now this one here is specific. Notice it's very, very specific here. One is you do an initial test. You see that? So you start with a failing test case, obviously, and then or a program input that triggers a bug. So for instance, say, like here, you are doing this test because you already want to find the problem. And then from there, then divide or split the input into smaller parts or components that involve inputting the data, the data or the code or configuration. So now, because now you want to see how it performs under certain conditions, you see that, and then from there, now then you test it in subsets. So you're going to test your app in subsets. So when you're testing it in subsets there. So because you want to see how it responds. Like for instance, you do the initial test where you can have maybe a huge text file, just put it in, crashes. And then from there, now divide that text file. If the text file is like 4 pages, then divide it into into 4 subsets. Test page 1, test page 2, test page 3, test page 4. One, you might be thinking that maybe the reason why your app crashes is because of the entire test file, but no, you discover that maybe page 4 has got a problem. And then while you're doing this test, page 1 tests okay, page 2 gives you okay results, page 3 gives you okay results, and then you get to page 4, gives you an error. And then you notice that all this time you've been thinking like, oh, wow, I can't handle huge files, but you can. It's just that page 4 or there's a paragraph in page 4 that was giving you problems. I'm just giving you a hypothetical here. I'm not saying that it's possible, but yeah. And then from there, after you've done this subtest there, and then iterate. Now, when you're saying iterate is divide again into smaller parts and repeat the entire process again. You see that? So that is the delta debugging there. And then the other one, soft squeeze. Now with soft squeeze now, yeah, we're talking about this here debugging method where or a technique. It's a technique basically of isolating failure within the test using a progressive. Like I'm trying to find a way. Okay, it's basically similar to that. But now you are isolating this test using progressive inlining of the parts of the failed test. See, like you have got to all those smaller subtests that you have, and then you delete the. Can I say delete? Like it's more like you remove the code after you have basically tested. If I am putting it like that, you guys can always just go on Google and try to check out how it actually works, because this one is very difficult to explain in words. It's very, very difficult to explain in words there. So I'm pretty sure also even here the person that wrote here couldn't even put it more in like in proper words, but you can just go and check it out on Google and how it actually works there. But anyway, so this here is debugging. This here is debugging. And now this debugging method just doesn't apply to SQL only. It applies to your entire app. Whenever you're dealing with app, and then the debugging actually works there. And the reason why we're talking about it under SQL is because we are assuming that a lot of the data that you'll be working in you'll be dealing with, like you'll be dealing with using databases, e.g. I'm pretty sure, let's say a client comes to you and asks you to make a web app. So now if they want to change the price, for instance, like for instance, the project that I gave to you guys, and then you want a client to be able to change the price, the client wants to be able to change the price at any time, but they do not want to come to you to change the price for them. They want you to design the system, and afterwards, they want you to make it work in such a way that they can change the price on their own without involving a developer. So which means now a client has to be able to make use of a database that is going to handle that information, isn't it? So this is why we're talking about databases here, so that they can be able to update the database on their side, and then when they update the database on the side, it's supposed to reflect also on the client side there. That is why, because you want to apply your client to be able to have, you know, that leeway there. Now, when it comes to now the specific outcome 5, now document the programs for a computer applications. Now, how that do we document? This is what I was talking about there. That each and every program that you are going to use, that you're going to design, like for instance, what you guys are working on right now, you're supposed to be designing a document. You're supposed to be designing a document right now. So now, one is the document enhances the understanding of the program code. Because whenever you've got a document that has been written down, it's like you're writing an English, you want to write an English essay. How do you write an English essay without planning for it? Because you're supposed to have a plan, like a mind map of some kind. And then that mind map there is supposed to give you ideas like, okay, my topic is this. And then from there, I've got an introduction. And then from the introduction, then I've got 10 points that I want to be tackling there. I've got point 1, point 2, point 3, point 4, point 5, point 6, all the way to point 10. And then afterwards, then I've got a sort of a conclusion. And then now, already now that I've planned, I have got an idea on how exactly I'm going to start. And I've got an idea on how I am going to expand my points. And then from there, then I've got to conclude. Same applies with apps. Same applies. Like whenever you're thinking about an app, you also supposed to have that understanding of documentation that, okay, I'm thinking of an app. So this is where I am going to start. So let me see. Yeah, let me check. I think I've got a document somewhere on my computer. If I can find it, let me just give me a minute. Let me check for it so that I can show you an example of what we call documentation. Okay, so while I'm waiting for my documents to open up, I've got two of them. I'm not the one who wrote those, so I'm pretty sure you guys can see. Can you guys see the documents that I have open here on my on the thing here? There's one that's written Team Skyward, and then there's another one. I'm just gonna open it. If you guys can see, just confirm for me if you can see my PDF. Um,
Yes, we can see your screen.
Okay, cool. So now, if you observe here, there's two documents that I have here. One is Atlanta Regional Commission. These are just simple documents that I have from companies that are actually existing. And these are documents that show you certain system architectures. Um, One is quite long, the other one is very short. So I'm going to start with the short one there. Notice here, this is a software design document. So now, each and every time I was saying that we need to have these documents here designed, and then table of contents, notice introduction, implementation, architecture overview, module interface description, implementation, course conclusion, reference. So now what you have here is basically in the introduction, you're defining your project. Like I'll come also here. You notice there the purpose of this whole software design document. What is its purpose? Who is the audience? The summary of that. You see, so basically now you are coming up with the entire app. What exactly are you to? What exactly is your app going to be dealing with? You notice, so like here they're saying that serves as a what. This is the company here. They're talking about it that serves what. All of that stuff there. And the next thing is now they start coming up with a problem. This is the problem that they're facing there. They've got this problem. So first up is the company. They're talking about the history of the company and everything else, what the company does. Next thing, they're talking about what the problem is. And the next thing, now they're talking about the app. They start talking about the app there. And then from there, and then they come up with an overview of what the app is about. And then all the way now, the purpose of designing this particular document. Why? So the documents say that the SSD document tracks documents and tracks the necessary information that is required for effectively to effectively define architecture and software design in order to give the development team guidance of the architecture of the system developed, and then design documents incrementally. You notice that it's a document that is a current document that changes with time, but the whole point is it documents the entire system as you go from step A all the way. And then from there, we spoke about the audience. So this is the audience there. Let me see here. Okay, here they're telling you how exactly it works. You notice that the following additional major function for the users requested to be added to improve web-based reservations, automated scheduling, provider management, trip provider assignment, automated dispatching. You see that all of that stuff. And then from there, and then they start talking about the system overview. What does the system do? And the goal of the system, what is it supposed to do? So you see that integration with another web app, and then ability to create clients, and then trip triangling, and then ability to schedule a trip, ability to pay for a trip, ability for the ARC or service provider to charge a fee, and then information on the schedule or the routes and stuff like that. And then they're talking about trip booking there, talking about payment and booking, data analysis, module system, and then integration with third party systems like Google Maps, the Google software, and things like the route planner, all that stuff. You see, so everything has been touched whenever you have on your document there. And then they are telling you the type of the users there who are going to be making use. Then you've got the travelers, you've got friends, you've got agents and customer representatives there, you've got agents administrators, you've got provider administrators, the administrator. You see that all of these are the users. You've got system administrators as well, which are going to be managing the software. And from there they list all that stuff, and then from there then they go through that design constraints. They're talking about the different problems that they're talking about, the finance, they're talking about the technical skill, they're talking about the institutions there, and then future contingencies there. How are they going to be making use of all these third parties and stuff? See, and then from there now they start dealing with the software in play, going all the way down. You see, so this here is what you call documentation there. Then they start defining the different people that will be used there. See, the responsibilities, you've got a project manager, you've got a lead designer, you've got a software architect, you've got a software engineer, you've got a quality assurance lead, and like all of these guys are the ones that will be responsible for designing the app, but each and everyone has got a different role, obviously. Then the architect and the design and the engineer, they've got different jobs there. And then from there, you've got your concerns and you've got these outlooks, operational environments, moving down. See, they even have got like some sort of a structure on how they're going to be making to be linking. You see that this is a database and it's linking to the Amazon Web Cloud using a secure VPN connection. You see that they're showing you there that they're going to be using something called infrastructure on demand, which is basically infrastructure as a service, IaaS, and then cloud computing there. So they're literally showing you that different um, items that they'll be making use of. Notice here. So this is what they'll be making use of to design the software. They've got GitHub, they've got Amazon Clouds, Amazon Web Services, they've got Force.com. They are going to be making use of PostgreSQL for the database. They're going to be making Bootstrap for the UI. They're going to be using Node or Node.js for the back end. They're going to use React for the front end. They're going to use also native React for the mobile front end. Then they're going to use Apex for that Force.com thing, cloud computing platform that they'll be making use. So if you notice there, you've got all your technologies that you're going to use. You're also supposed to list all of these things there. This notice here. And then now they're telling you about what the platform here, they're saying that the platform as a service is the next step for this particular software, which is the next step down from software as a service there in the cloud. PaaS provides the following there. You've got all of that stuff there. The current applications as a PaaS there. This is how they're making use of these items there. They're using Ruby Rails, they're using Node or Angular, Java. So they are still thinking here on what they wanted to use. But now they say that, oh, the current application utilizes these aspects there. But now the updated applications, this is what they want to make use of for them to start designing their website. You see the things that I was telling you about the the latest technologies. These are the latest technologies that are basically used. Hence, you've got your Node, you've got your React. See, React uses JavaScript. Node uses JavaScript. Bootstrap SQL is still SQL. See that? And then some of these you will learn on your own. GitHub, we're simply going to look at it sometime later. React is basically the same thing there. So, but if you understand this, and then you are sorted. You are sorted there. So then now performance engineering, and then they're telling you how this is going to be made to be working. You notice that the structures there, the APIs. Now APIs are basically the application interfaces. So what you'll be linking. For instance, if you want to use Google Maps in your app, you are going to make use of a Google API. So that is what they're simply talking about here, about like joining other systems or other architectures into your app there. And then you've got sort of a hardware architecture. You see that? This is how it works. So you're literally telling us how exactly it works there. And then, for instance, there you notice there's a web server, there's an application server, there's a memory cache, which is the back-end side there. And then you've got your databases here that are interacting with the back end. And then you've got your requests here that are linking to your users, all your users there, and then are basically linking to using HTTPS, which is a secure network, which is what you're making use of. Then all of these items, they get information from your main server, which is using your background languages like your JavaScript or Node in this scenario here. And then you notice these are some of the languages that you're making use of there. It is up to you at the end of the day. And then you've got your system requirements. Like, okay, I'll be making use of a web server. This is the name of the web server, and then it's going to be what. And then the storage is going to be where, and then all of that, and then the database server. You see that you've got all of these stuff there. And then from there, you still have got that basically a system architecture I was talking about there. So now this is more of a simplified diagram there that you have, which is basically the same thing. So notice MySQL there, which is basically your database that is being used. Some other people that would prefer to use Mongo, but depending on what you guys use, because at the end of the day, like you do not want to overload yourself with information. But one thing is that your app interacts with the web server interacts with the database. But for now, you guys will be interacting directly with the database, but using a server somewhere. So your server is always in the middle there, always in the middle there. You've got your MySQL server that you guys are going to develop. So whether your MySQL server that you're going to make use of is going to be a web server that you're going to upload on the in the internet sometime later, and then you're going to use. So web servers can be, like your cloud computing servers like Amazon, Google, and stuff. That is all up to you, IBM and stuff like that. That is like the one of the simplest things that you guys can ever do anyway. Understanding these the cloud computing, of which you need to know that you are living in 2023 as a developer. You need to understand cloud computing at this day and age now. Yeah, and then now you notice this interaction that I was talking about there, and then you still like there is a lot that you guys need to have, and you also need to have this. This here is what you call flowcharts. You need to have a flowchart. How does your app interact? The pages that you have, how do they interact? How do they talk? Like for instance, if I click on the login page, what exactly happens with the login page? I'm supposed to have that entire diagram there that, oh, okay, if I'm successful, I'm supposed to go there. If I'm not successful, I'm supposed to go. I'm supposed to have this flowchart there. And notice here, still talking about the architectures and stuff like that. And I'm trying to, oh, this is the database design. I'm pretty sure you guys saw this last time when I was showing you databases on MySQL. I actually showed you this, that you're supposed to have these links that you have. You notice there's even relationships here that actually indicated. So I can even zoom it in so that you guys can see what I'm talking about. Notice the account taxonomy links to account. There is a certain relationship there, which is a 1 is to oh, this is a many is to 1 relationships. One account has got many account taxonomies, and then you've got a task that links also to the employees and stuff like that. Like this here is just like an example of what you call a database design thing. But you need to have that data object and structures. You need to have these, which are basically algorithms on how you think if you're going to be making use of what you call this, like whatever that you're going to make use of. We need to know what exactly that I'm going to make use of. Like here in this case here, they were simple writing the names of the database of the fields in the databases here in the data structure. These are the names of the fields that they have in the databases. And notice a database management system, which is basically the same thing there. Data conversions, you notice there's inputs, there's outputs. How do you convert the data that you have? You've got forms, you've got inputs, user models, you've got permissions, all of that stuff. And then you've got the user design. You notice there, you're supposed to have some sort of, a design that you're expecting to have. Like here, this is their user design. This is what they want in their front end. This is what they want it to look like. That's why they call it a mock-up. They want it to look something like this. See that? And then you've got all these tabs there. You can click on customers, you get information about customers. You click on vehicles, get information about vehicles. Click on drivers, get information about drivers. Click on reservations, get information about reservation routing. tracking. You've got all that information that you have there. And then from there, and then you've got, these scenarios that you have. So now this here is a document. So I'm not going to go through each and every aspect, but I'm pretty sure you guys have got a general idea of what we're talking about when you're talking about a document. So in this case, now going back here, you notice that each and every app that you have is going to be able to have a document. And now talking about a database here, did you notice how big the aspect of a database is, especially on the document side? Because it is that important. Are we guys on the same page here? Can you understand what I'm talking about? Hello? Are we on the same page?
Yes, sir.
Okay. All right. So now going back here. So when it comes to the document now, like you need to document that. You see the document associated with software project and the system being developed has a number of associated requirements. One is supposed to be a communication medium between members of the development team. That is why if you are working on your own, you still need a document to guide you for your client purpose, because you need to tell your client what exactly that you wish to accomplish, hence the documentation hand. You need to submit that to your client. Your client looks at the documentation and can say, okay, cool, you can proceed. Because that documentation there can save you a lot of work. Imagine now you develop an app for 6 to 8 months, only for a client to say, no, I don't like it. But if you have a documentation, you send the documentation over to the client after designing everything that you need, and then how your app is going to interact, and then from there you send it over to your client, and then your client looks at it and like, I like it. You see that? So what I'm going to do is this. I'm going to send both those documents there on WhatsApp, on your WhatsApp pages for both Joburg and Cape Town. So I'm just going to upload them, and then you guys can just peruse through those two documents there. Yeah, what is waiting for my thing to send it through? Yeah. And then now, product documentation is concerned with describing the delivery of the software product. And then user documentation, this one here is users of the software are not the same. Hence, you need this different type of user documentation. Hence, most times, what happens is we have one document. And then in that particular one document, and then you've got structures that you have that deal with the different users that you have. Like in this case here, let me see something here. Now, I do not have that. I do not have that. But in most documentations, you notice that each and every user have got their own section where it deals with the different users that you have, and then tells them how to interact with the app. Because you need that. You need that aspect there on how exactly does a user interact? What is their job in all of this? How do they interact? How do they use the app? There's an app last time that I was checking out, and then I think those guys are open source. And then that app there, they've got user documentation that they actually have. that they actually have. Notice here, I'm looking at this the other document that I have here. Then the other document, notice here, they're making use of Django. Django is Python. They're making use of it with Ajax, which is basically JavaScript to request for information. And I'll prefer to use Node because now I don't have to teach you Python. Otherwise, you guys will need to learn Python. Python will take a very long time for you guys to learn. So hence that. But yeah. All right. So yeah. Oh, by the way, notice here, we've got version numbers of that document. Notice we've got draft number 1, which was made, and then draft number 2 was updated with revisions, draft number 3, but the final draft was made sometime later, almost 3 months. Oh, actually 3 or 4 months, 4 months later. You see that? And then we've got draft number 5, draft number 6, draft number 7, draft number 8. See that all of these are different drafts of the same document that you have, because these documents have got drafts, especially because it gets updated every time there's a change. A client can come, for instance, you can make the initial date, send it to a client. The client says, okay, can you change APC? You change APC, and then afterwards, and then the client comes and says, I know what, I've changed my mind on that and stuff, or can you do this and do that? These are the revisions that you're basically talking about there. And then after everything has been done, and then you can make another draft, and then you have got the final draft. That is actually the working document. This is a document that you're going to start the app using. So before you get to the final draft, you cannot design the app because you can't design the app on an initial draft. So you have to design the app on a final draft. That is why, like, if you check there are these kids in grade 12, actually 10, 11, 12 in high school that do a subject called IT, which is basically coding, which is basic computer sciences. For some reason why the DBE decided to say IT, but it's computer sciences. Now, in that subject that they're doing that, they design apps. For instance, like they've got projects, all of them, which is basically something that takes them almost 6 months to 8 months for them to complete. They make apps. So in that app that they're making, which is basically a web app that they're making there, and then in those web apps that they're making, they have to, the first thing that is needed from them is a document, which is called phase 1. They have to submit a document entitling each and everything that they're going to be doing, what the app is about, what exactly they'll be doing, how exactly they want to use that app, how exactly are they going to join that into a database, how is the database going to interact, the front end, and how it's going to work, the back end, how it's going to interact. They do all that stuff from grade 10. So now understand now that the documentation is very important because it's actually worth a third of the marks. So of the marks that they are given, 1/3 of the marks come from the documentation, just to show you how important this particular document is. See, so now documentation in any software development is very important. Hence, now whenever you're making it, also you're supposed to have these users also that are catered for in this particular documentation there. So as I said, that there are so many different versions of this documentation there. So like here, they're simple talking about the user documentation, and then next up is what they call the system documentation there. Now, the system documentation talks about the basic system, but now, as I said, guys, you do not need to separate this document into these smaller documents. It's one document that covers everything. It covers from number 1, from what they call the product documentation, whereby you're talking about what exactly the product is about. You're introducing us. They're telling us what it is, what it does, and everything else. And then from there, you come and tell us about the users. Who are the different users that are going to accept? Like, for instance, I was showing you in the previous documentation that different types of the users there that were actually there. I think it was this one here. I just forgot the page. Oh, yeah, yeah. Yes, here. You say that these are the different types of the users there. You've got the individuals, you've got the bodies, you've got the agents, you've got the agent administrators, you've got provider administrator, you've got system administrators. Notice these are the different types of the users that are actually using this particular app that is designed. So you need to be able to outline and describe all those um, users and their system requirements. How exactly do I deal with the system, and how do they install or use that particular system? Since they're using the website, they don't even need to install. But how do they make use of that particular system so that they can use it to its fullest capacity? And then next up here was let me see that introductory manual and stuff, system documentation. This here outlines the entire system. It describes the system itself. How exactly does the system work? You guys saw that. How exactly the system works, how it interacts, all the components, how do they interact and things like that. And then from there, system maintenance and all that stuff, all that's part of the system. And then you've got the quality. Now, this here is a problem. Hence, that's the reason why I was talking about that. These kids actually marked also for the documentation because quality matters. Because if there's one thing that I will tell you right now is I do not know a single software engineer or software developer who actually likes writing any form of documentation. Not even one. I've never met one who said, nah, I enjoy writing documentation. Even right now, if you go on YouTube and you go and watch those videos live or live of a software developer, you go and watch those videos there on how those guys work. One thing that will always tell you, one thing that will always have like one thing that they have in common is hate documentation. Now, I hate documentation, but it's needed. It needs to be done, and it needs to be of very, very good quality. It needs to be dated. You see that? So it needs to be easy to understand. It needs to be complete. Hence, all these versions that we have and the dated versions for that matter, because it needs to be current. As you are working through the project, you're also updating that documentation because it's needed. Say that it has to be a very, very big, good quality there, because it makes even your app later when you're done, it's very, very, very easy for people to be able to use your app. And then the structure should be in a certain structure, a structure that is easy to follow. Now, if you go through these particular documents that you have there is a structure. You notice there, you've got that structure: introduction, general overview, design, general considerations, system architecture and design, system design, operational scenarios. This here is basically when you are like literally more like testing and stuff. And then you've got design, detailed design, and system integrity controls, and then you've got all these APIs and stuff like that. You see that? And then if you go to the other document, also it is almost a similar kind of structure there. You notice there? See? Introduction, implementation overview, architecture, model and interface, implementation plan, and then you've got your conclusion, you've got your references. Basically, because it's the same, it follows the same structure. There has to be a certain structure in your documentation there. And also your document has to maintain industry standards. It has to be according to IEEE standards for writing and user documentation. Because if you check, like most times, any documentation that doesn't meet, it will make your app will not be accepted if it doesn't meet certain standards. So your app has to meet the documentation standards, because most times it's because before you submit any app, you need to submit the documentation. They need to check with the documentation if the documentation is clear, so that they can understand what your app does. Because they will not be able to go through your app, but they can be able to go through your documentation there. And then process standards. Now, these are they define the approach to be taken in when you're producing the documentation. Generally meaning that defining the software tools in which should be used for document production, and defining, let me do this. Oh yeah, I think I can send this now. I'm trying to see the date. Today is the 12th, so let me do this. What's the date today? 11th.
11th, sir.
Okay, thank you. All right, send to the other group and send to the other group also as well. All right, sent. You guys have here the document, those two documents there. You can just peruse through and check them out. Okay. Yeah. Okay, I sent that document, so I hope you guys can see that. Now, you guys can go through those two documents there just to see what you're talking about when you're talking about these documents there. So as I say, that quality there matters, and it has to be of industrial standards or the accepted international IEEE standards, if I put like that. And then the product standards there applies to all the documentation that are produced on the course of the software development process. See that they have to be consistent. Like your documents have to be very consistent. They have to be, excuse me, project specific, and yeah, they have to be very, very project specific there. So you can just go, excuse me, you can just go through your documents for you to find out what exactly we're talking about when we talk about documentation there. And then this is the next module that we'll be visiting here, which is basically demonstrating an understanding of the computer database management system. Now, we've been talking about this a lot, but we haven't really touched on it. What exactly is a computer database management system? So now, starting from there, before I can go forward, is there any question special related to the stuff that we've been looking at, that we've been talking about? Is there any question, anything from your guys' side? Hello.
No, we don't have any questions.
Okay. Thank you, Tsepo. All right. So
Sorry.
oh yeah.
Sorry.
What's up? What's up, Troy?
Yes. Let's say for instance, right? You want to just excuse me for a moment. Okay. Let's say for instance, you want to you want to host, right? Let's say you want to host a certain website and then you don't have a web server. Obviously, you're going to outsource it to another company that is going to grant you the space, obviously. So I just wanted to know, I just wanted to know that in terms of, you spoke about, what is it? I just forgot because the question was there. Like I had it in my mind. So let's say you wanted to host a certain people, obviously, but you're keeping their database, but they want access towards their database and which you are the one who's hosting it. But obviously, what you call these people, the cloud people on the other side, as a mother company of you renting the space to them. So can you give those people the rights? What I'm asking, can you give those people a rights in order to have liberty to access the database which you are hosting, and then obviously they grant you that job of
Okay.
hosting? Yeah.
Question first. When you're saying access to the database, what do they want to do on the database?
Probably maybe they want to jump ship. They just wanted to see you. They just wanted to see that, oh, okay, this guy is capable of pushing this capacity, but we want to employ another company beside us. So that's what I'm asking.
So, like, they want to be able to update the database.
Yeah, in essence.
Okay, if they want to update the database, then develop an interface, like an administrator interface where they can actually be able to update the database. Because one thing is, giving someone access to the database is going to come back to bite you at the end of the day, because whatever that they do, if let's say they delete a certain field on the database, it will crash your entire app.
True.
Yeah. So now when that happens, and then you are the same person that has to go back and fix it. And now, if now that kind of a disruption on the database, it means a total rebuild of the app.
Yeah.
So now, if there's one thing that should never be given, especially even to the company that runs the website, unless if the person that wants to touch is a developer like yourself, is a database. You don't give anyone access to the database, but you can give, like, if they want to manage their own app, you can give them management of their own app. But which means they have to take ownership of the entire thing, because you cannot give someone access to the database while you don't give them code. So which means if they want the database, which means they want the app, because the database makes the app.
Sure.
Yeah. So they have to decide between the two. It's either they let you host everything, or if they want to have access to the database, which means literally what they want is to host the app for themselves, then you give them access to that. Like, oh no, you can host it yourself. Because if anything happens, they will come back to you, and then they'll always come back and say, I didn't do this, you did it. Now you've given yourself extra work for nothing.
Okay. No, understood.
Okay.
I can mute. What's going on?
I can mute for you. Oh, done. All right. So I say that I want us to start on this outcome here, the database, understanding of the computer database management system. Now, what exactly is this whole thing that we've been talking about? Now, busy talking about database, this, database that. What is a database management system? Now, when you're talking about a database management system, there are certain aspects that we need to do. Like, we need to understand the different types of these database management systems. We need to know what exactly it is that you're dealing about, the issues, and how the database management issues are, and how they are addressed actually using a database management system. Like, to answer some of the questions that Troy has here, we'll be tackling them here. I'm pretty sure a lot of you also are asking yourself more or less the same questions there. So these questions are going to be answered as we explore through this module here. So now in this part here, now what is a database management? Let's start there. Before we even look at database management system, we need to understand database management. So now, What is database management? Now, database management is the development and execution of architectures, policies, practices, and procedures in order to manage the information lifecycle and the needs of an enterprise in an effective manner. Seems like a lot of jargon, like whenever you read that. So in layman, what they're simply saying here when they're talking about database management. Now, database management is, if I can put it like this, let me see. Now, it's basically you know, the process, if I can put it like that, it is basically the process of effectively and securely storing, organizing, and managing data within a database system. That is what database management is. Basically, that process where how do I effectively store data? But even if I'm storing data, how do I do it in an organized manner? And how do I manage that particular data? See that? Because these are the biggest issues that we have right now. Like right now, the age that we're living in what they call the big data age. That is why I've said this so many times that we're living in an age where the most expensive commodity that we're selling right now is data. Look at all these major companies that you have. Their focus of business is data. Amazon, their largest selling their largest selling commodity is data. Apple, what do you think people like? I don't know about other people that are buying iPhones and stuff, but why do you think the iPhone is the preferred phone around the world right now? It's not because of prestige, but it is because of them understanding data protection. Because Apple has got the most secure software in the world right now. The most secure software in the world right now is any Apple that is any software that is actually manufactured by Apple. Highly secure. I'm not saying that it is 100% hack proof, but it is almost close. But a lot of these Android is open source. Anyone can do anything with Android. Anyone can do anything with Windows. Anyone can do anything with Linux. But Apple protects their stuff, and that is the reason why some of their products are selling so much, because understand that it's so difficult for you to hack into an iPhone and get stuff from people. But right now, if you come and hire me to come and hypothetically speaking, hack into an Android phone, it's so easy to do that. Like if you guys didn't know, it is so easy to hack into an Android phone. But to hack into an iPhone, it's gonna take you some time. Like by some time, I'm talking more than 6 months to hack into one phone, which will be pointless at the end of the day. So hence, you understand that aspect of data protection there. So hence now, when we're talking about database management, this is what we're talking about there. How to efficiently store, organize, and manage data within a database system. That is what we're simply talking about there. So now, how do I do that? So now, there are certain aspects there. Now, after you have understood now what database management is, then now, why do we have to go through all that stuff? That is the major question, is why. So now, why is described here in the database management issues. One is technical data is not recorded properly. So this is one of the reasons why, like notice there's some briefly described issues there or problems that arise in management of data. One is some of the technical data is not recorded properly there. This occurs when in research programs, when data is not recorded in accordance to the accepted standards. Like for instance, like other people do not even know how to design proper databases. Other databases. Yes, sir.
Yes, like I need to understand. Yeah, between, like, as you are making an iPhone is an example.
Yeah.
So there's Windows 11, like I think the security has been improved. So like, can you tell like the difference between Windows and iPhone?
Okay. Windows. Okay. I'll tell you from the iPhone perspective, right? From the iPhone perspective is that the software for Apple is written for hardware. So any software that you have for Apple has to have, like, before you install any software for Apple, there is a certificate, or we call it digital certificate, that was written on that device that you're using. So before, if you want to install software, there has to have a handshake first between the hardware and the software. There has to be a handshake between the two. So hence, you cannot install anything that doesn't have the certificate from Apple on an Apple phone, or on an iMac or anything. So that is why, like, when I'm talking about the security aspect, I'm talking about that aspect there, that it's so difficult to install any third-party softwares on an iPhone or on an Apple device for that matter, because of the hardware configuration and the acceptance there. Because Apple hardware is not designed to accept any other software unless it has been pre-approved by Apple. Now, when it comes to Windows,
In case
eh?
they are so strict to their policies.
Exactly. So now, for them, is the right software for their devices. So any software that has not been accepted, which means that software is not given a license for, so which means even the hardware, when the hardware tries to interact with that software, there's no handshake between the two, because the hardware doesn't recognize that software, because it doesn't have a license for it to be able to be installed on that particular phone or laptop or anything. But unlike now, when it comes to Windows, Windows doesn't do that. Now, Windows writes software, as much as Windows 11 is secure to an extent, I'll put that in quotes. It's secure to an extent, but it is also what they call, what do they call that? Like, it can be used by anyone. That is what I'm trying to say. And it can be installed on any other device. Like, if you check, you can install Windows on any, as long as it's a computer that has a hard drive, that has RAM, or the specific RAM, a specific hard drive and stuff, you can install Windows on it. Do you see what I mean?
Yeah, and now, yes.
Okay. So yeah, I hope KB understands what I was saying there about that whole interaction between hardware and software.
I do get you now, sir.
Okay. So that is one of the reasons why Apple softwares are so, like, are secure. It's because of that aspect there of licensing. It's all an issue of licensing and the handshakes between the hardware and the software. Because if the hardware is not be designed to accept anything, and then it's so difficult to hack into that thing, because it limits your, like, your options. All right. So now I was talking about the technical data being incorrectly recorded there. So I was saying that it's when technical data is being incorrectly recorded, it makes it difficult for the interactions there, or for your data to be stored in an efficient way. And then number 2 is technical data management is not supervised. Now, in this situation, the principal investigator might inappropriately delegate his or her oversight responsibility to someone in his or her lab that is inefficiently trained. Like here, it happens this a lot, that the technical data, for it to be incorrectly recorded, is mostly because the technical data is not properly supervised. Like you find that there's someone who's so-called a database administrator, but who doesn't understand the relationship between the databases that you have. And then from there now, when it comes to creating databases and stuff, and then they allocate certain things where they're not supposed to be. And then now when that happens, and then the data will be incorrectly recorded because of the supervision issue there. And then data is not maintained in the institution. You see, here, this one here can lead to a lot of data redundancy here. Because now, if data is not maintained in the institution, which means one is you can have data that is very old, and 2, you'll be wasting a lot of space because you've got data that is unnecessary, that is supposed to be deleted. Like for instance, let's say you are operating an organization that has been in existence since 1980, for instance. And then in 1980, there are certain companies, maybe let's say half of the clients of that particular company have closed down in the past 20 years. They haven't been operating for the past 20 years. So now, do you still need the data in your database? No, you don't. That data needed to be removed long time ago. It will be problematic because now that data is there and occupying space, and you do not even need that particular data there. Hence, it needs to be deleted. This is one of the reasons why, if you check companies like Google and stuff, if you don't use your account for a year, they'll delete your data. They'll actually send you an email, 1, send you an email, 2, then final message when they send you an email, they're actually telling you that we have deleted your data because you haven't been using your email account or your Gmail and stuff, because they want to reserve space, because the more data is there, the more space it takes. And if that data is not being used, then they'll rather delete it. See, financial and administrative data are not properly maintained, which is basically the same as that one there. There are certain files that you do not need that needs to be removed, so then they have to be removed there. Data not stored properly. See, sometimes data is not stored properly, and then that becomes a problem because now it, as I said, takes space. 1, 2, it is also easy to hack, and now because it is easy to hack, and then it becomes more of a problem later when it comes to security, because people will be suing your company because your company is not protecting their data enough. That is what is happening with Facebook, with TikTok, because people are feeling like their data is not being stored properly. So anyone who's got certain money can actually have access to their data. And then also data is not held in accordance to retention requirements. So yeah, retention requirements is basically that thing that I'm talking about, the security issue there. Hence, you've got these unending lawsuits there, intellectual properties and stuff, because your data storing there is not properly done. So it's easy for people's data to get leaked and to be used for whatever reason. And then sometimes data not retained by institutions. Some institutions, they delete data whether by mistake or by choice, they do that. And imagine now you are running a company, and your company, you are hosting, maybe let's say clients' things on a certain web server using their cloud computing devices and stuff. And the next thing, that company, after maybe 2 months, and then you want to access your client's data, and your client's data is gone, which means that particular institution is actually not returning people's data, and it's a problem. And like myself, I think I was actually what you call this, I was hosting a certain website. Actually, it was an app, a certain web app with a certain service provider. And then that provider there, that a certain payment issue at one point. And then after a month, then they delete my stuff. And then once that thing is sorted out, then I'm like, okay, cool, bring me my data back. And then they're like, no, your data is gone. We didn't even make a backup copy. I was like, no, like you can't do that because now they've made me lose my data, the data for the client that the client had, and the client wanted that data. Now we had to do a back and forth there. They had to go back because it became a big issue, and the client now, and it was an institution at that time. Then the institution started suing the company because they couldn't sue me. I didn't have that much amount of money for them to sue me, but that institution there had to find a way to get that data back. They eventually got it back. But now you notice that it's bad business practice if you do not return client's data. You see that? So I think for today, let me stop here before I go to database management systems. And this is where we're going to continue from, as from tomorrow. This is what we'll be looking at there. This entire module. So I hope you guys are on the same page, and there's no one who's left behind. And we're done with module 1. I'm pretty sure you guys are busy with your, is it formative or summative between the two? I hope you guys are done with whatever, or you are busy with that one now. So yeah, tomorrow, and then we're going to continue from where we left off from, excuse me, the database management system, and then we'll be talking about what it is, and then the different advantages and the different properties of the database management systems. So this is what we'll be looking at there. And then also we'll be looking at the specific outcome 2, where we're looking at the commonly implemented features of commercial database management systems. So we'll be looking at all these like tables, objects, things like that, so that we can get to understand that. And obviously the system outcome 3, which basically talks about the different types of database management systems. So we'll be looking at all that stuff. Because this one here is quite a very, very small module. So I think we'll be covering this in the next 2. I think by tomorrow, we'll cover all these databases together, DBMS, the whole thing on DBMS by tomorrow, before we move on to module 3. Now, module 3 is exciting. Yeah, will be exciting, this one here, because this one here has got a little bit of work. So this is where we're just gonna have to start from Wednesday. So if we do not have any further questions, I think we can end here for today, and then tomorrow we're just gonna finish up on this. Wow, Busi is fast, ne? Okay, Busi, I see you very fast. All right, so guys, all the best in your work, and then we'll meet again tomorrow. Have a good day. Talk tomorrow.
You too, man.
Thank you, sir. Bye, everyone.
Bye, everyone.